Welcome to Study Loop.
Hi, in the given problem here, there are two toroidal solenoids. They are as shown in the figure. One of the toroidal solenoid, which we can say as the primary toroidal solenoid, because there is a magnetic field at its axis, along its axis. And this toroidal solenoid is having number of turns N1 and radius is R, the average radius. Suppose the current I is passing through this toroidal solenoid. Then another toroidal solenoid which is also coupled with it. This is. So this secondary toroidal solenoid is having number of turns N2. Both of these solenoids are having the same area of cross section, which is given as A. So in the first part of the problem, we have to find the mutual inductance of these two toroidal solenoid. So first of all, the magnetic field associated with the axis of primary toroidal solenoid B1. Magnetic field linked with primary toroidal solenoid is mu naught N1 by 2 pi r, because here it is the number of turns per unit length, and here length is the circumference. So N1 by 2 pi r into I. So this is the magnetic field associated with the primary solenoid, toroidal solenoid. So the magnetic flux, the total magnetic flux linked with secondary solenoid will be phi 2 is equal to number of turns, total number of turns in this secondary toroidal solenoid into B1 into A, area of the toroidal solenoid. And as both the toroids are having same area, so here this is A. So it becomes N2 into mu naught N1 I by 2 pi r into A. And as we know, the expression for total magnetic flux is also given as M into I, where M is the mutual inductance. So equating these two, we get to know Mi is equal to mu naught N1 N2 Ia by 2 pi r. So cancelling this I here, the answer for the first part of the problem means the mutual inductance of these two toroidal solenoids comes out to be mu naught into N1 into N2A by 2 pi r. This is the answer for the first part of the problem. Now, in the second part of the problem, we have been given the values of these parameters. For N1 means the number of turns in the primary solenoid, toroidal solenoid, this is 500. N2 is 300. Area of cross section is 0.800 centimeter square, which can also be written as 0.800 into 10 raised to power minus 4 meter square, and radius is 10 centimeter or 10 into 10 raised to power minus 2 meter. So numerical value of mutual inductance will come out to be, for mu naught, this is 4 pi into 10 raised to power minus 7. For N1, this is 500. For N2, this is 300. For area, this is 0.800 into 10 raised to power minus 4 and divided by 2 pi into r, which is 10 into 10 raised to power minus 2. So this 2 pi will cancel 4 pi, giving just 2. Then this 500 into 2 will become 1000. So here this 10 raised to power minus 4 and 10 raised to power minus 4 will be 10 raised to power minus 8 into 300 into 0.8 will become 240 divided by 10 raised to power minus 1 Henry. So finally this mutual inductance in magnitude will come out to be 240 into 10 raised to power minus 7 Henry, or we can say 24 into 10 raised to power minus 6 Henry, or finally this is 24 micro Henry. This is the answer for the second part of the problem. Thank you.